Hello, hello, and welcome to Chapter 7, Lesson 1. We're going to be looking at factors and the greatest common factors. So the objectives for today are to write the prime factorization of numbers, and then also find the GCF of monomials. All right, so let's go ahead and get started. All right, so the whole numbers that are multiplied to find a product are called factors of that product. Let's read that again. The whole numbers that are multiplied to find a product are called factors of that product. So I'm just going to think of two whole numbers that are multiplied. So like 2 and 3, right? 2 and 3, those are whole numbers. And they're multiplied, 2 times 3 is equal to 6, right? So these are the whole numbers that are multiplied to find a product. So this is our product. And these are called factors. Okay, of this product. So 6 is made up of the factors of 2 times 3. All right, I'm going to read that again. The whole numbers, remember whole numbers, those are 0, 1, 2, 3, and so on, right? So all the counting numbers, like if you were to count pens, like how do you count these? Well, you count them like 1, 2, 3, 4, right? So the counting numbers, however you count, plus 0. No decimals, no fractions. Those are what whole numbers are. So the whole numbers that are multiplied to find a product are called the factors of that product. And a number is divisible by its factors, right? So these are the factors. So this number, 6, is divisible by its factors. So if you go 6 divided by 2, you get 3. Or if you go 6 divided by 3, you get 2, right? So the product is divisible by its factors. Let's think of another one. So how about like, I don't know, like 5 times 8. Those are both whole numbers, right? And 5 times 8 is 40. That's the product. So these are whole numbers multiplied together have a product. So that means that 5 and 8 are factors of 40. Okay? And also, these factors, this number is divisible by its factors, right? 40 divided by 8 is 5, and 40 divided by 5 is 8. All right? You can use the factors of a number to write the number as a product. You can use the factors of a number to write the number as a product. So I think what they're saying is instead of writing the number of 6, you can break down 6. 6 is the same thing as 2 times 3, right? So you can use the factors, these are the factors of a number 6, to write the number 6 as a product. So 2 numbers. So instead of writing 6, I can write 6 as 2 times 3. It's the same thing, right? Or instead of writing 40, I can write it as 40 as a product of its factors because 40 is the same thing as 5 times 8. Okay, so that's what that's saying. You can use the factors of a number to write the number as a product. The number 12 can be factored several ways. So this is called the factorization of 12. So how many different ways, like 6, right? We wrote it as 2 times 3, but we could also write 6 as 1 times 6, right? So that means that 1 is a factor, 6 is a factor, 2 and 3, those are all factors. And the same is true for 12. The factors of 12 can be written a bunch of different ways. You can write 12 as 1 times 12. That's one way. Or 2 times 6. That's the same thing as 12. Or 3 times 4. That's the same thing as 12. Or over here, they're getting a little fancy. 1 times 4 times 3. Well, yeah, that's the same thing as 12 too. Right? 1 times 4 is 4, 4 times 3 is 12. Or even fancier, 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So these are 1, 2, 3, 4, 5 different ways to write the number 12. All of these mean 12. Okay. So the order of the factors does not change the product. So let's say if we were talking about, what were we talking about? We were talking about 6. So what do we have? We had whole numbers that were multiplied by each other to get the product, and these are the factors, right? So you can write 2 times 3, or you can write 3 times 2. That is equal to 6. So it's saying the order of the factors, these are the factors, right, does not change the product. So whether you go 2 times 3 or you go 3 times 2, you're going to get the same product. The order, what number comes first and what number comes second, doesn't matter. So the order of the factors does not change the product, but there is only one example below that cannot be factored further. Let's see that. There's only one example below. So out of all these factorizations of 12, there's only one example below that can't be factored any further. I wonder what they mean by that. Let's look at this, okay? So we have, let's look at this example. 1 times 12. Well, 1 is a prime number. Remember a prime number? A prime number has exactly 2 factors, itself and 1. The number 1 is not a prime because it only has 1 factor, just 1, okay? But like 2 is a prime factor because 2, it only has 1 times 2, that's it, right? Like it's a little different, like 12, you can see you can write 12 like 1 times 12, 2 times 6, 3 times 4, you know, there's all different ways to write 12. But 2, you can only write it one way, 1 times 2. Or what would be another prime number? Like, I think the next one would be 3, right? Because 3, you can only write that as 1 times 3. There's no other way to write 3 using multiplication as a product, right? Besides 1 times 3. What would be another one? What about 4? Would 4 be one? Let's see. 4, you can write 4 as 1 times 4, or you can write 4 as 2 times 2, right? So because of that's the case, this is not a prime number. But what about 5? The only way you can write 5 is 1 times 5. So that means 5 is a prime number. These are all prime numbers, okay? A prime number has exactly 2 factors, 1 and itself. What about 6? You can write 6 as 1 times 6 or 2 times 3, so that's not it. But 7 is a prime number because you can just write it as 1 times itself, right? Okay, so now that we understand what prime numbers are, this is saying there's only one example below that cannot be factored further. Okay, so there's 1, 2, 3, 4, 5 examples. Let's look at this. 1's a prime number. That cannot be factored any further. But what about 12? Well, yeah, we can write 12 a bunch of different ways. We could write it as 2 times 6 or 3 times 4 or all these different things. So this 12 can be broken down further, right? So that means this isn't the one. What about 2 times 6? Well, 2, that's a prime number, but 6 can be broken down further to 2 times 3, right? So it's not that one. What about 3 times 4? Well, 3 is a prime number, right? Just 1 times 3, but 4 can be broken down into 2 times 2, so that's not it. What about this one, 1 times 4 times 3? Well, 1 is a prime number, but 4, again, that's not a prime number. It can be written as 2 times 2, so that's not it. What about this one, 2? Okay, so 2 is a prime number. 2 is also a prime number, and 3 is a prime number, so this is the one. This is the one that can't be broken down any further. So it says the order of the factors does not change the product. Okay, we talked about that. But there is only one example below that cannot be factored further. This one right here. The circled factorization is the prime factorization. Prime factorization, right? So prime factors, that basically means that every single one of these factors has to be a prime number. 2 is a prime number. 2 is a prime number. 3 is a prime number. So this is the prime factorization of 12 because all of the factors are prime numbers. So the prime factorization of 12 would be 12 is equal to 2 times 2 times 3, or we can write it as 2 squared times 3, right? Because 2 times 2 is the same thing as 2 squared. I don't know why I wear my 2's differently. Okay? So, yeah, that is that. I think we are ready to try an example problem. Let's do this. Okay. So what we're going to do for example 1 is we're going to write the prime factorization of 98. So we have to break this number down. 98. 98 is a big number. So when I do this, I like to just kind of make a tree. So I just start with 98 and I just kind of like, I don't know, like I just have like branches that go down. And I know that we did this at the beginning of the year. We did like divisibility, like if a number is divisible by 2 or 3 or 4 or 5. Let's just go over those divisibility because that helps with this. Okay, so how do we know if a number is divisible by 2? Do you remember? If it's even, if a number is even, then you know that it is divisible by 2, okay? What about 3? How do you know if a number is divisible by 3? Do you remember? Well, if you take, this is 98, and if you take the 9 and the 8 and you add them together, right, 9 plus 8 is 17. And if 17 is divisible by 3, then this whole number is divisible by 3. Well, 17 is not divisible by 3. So we know that this number is not divisible by 3. What else? What could we do? We could, what's the next one after 3? 4. Okay, so the rule for 4 is you take the last 2 digits, and if the last 2 digits are divisible by 4, then the whole number is divisible by 4. This isn't a very, like, easy one because, I mean, is 98 divisible by 4? I'm not sure, right? Well, you know what? 98 is really close to 100, and I know that 100 is divisible by 4 because 4 times 25 is 100, but, so that would mean that it would have to be 100, and then the one before, you'd have to minus 4, which would be 96. So 96 would be divisible by 4, and 100 would be divisible by 4, but 98 wouldn't be. But yeah. But I mean, if you had a number like 116, and you wanted to know if that was divisible by 4, and you look at the last 2 digits, and the last 2 digits are 16, and 16 is divisible by 4, then you could be like, yeah. So that's like an easy one. But when it's 98, it's, I mean, it's not as like quick as this one. You might have to think a little bit more. Okay, so what was 2? 2 is if it's even, then it's divisible by 2. If it's divisible by 3, you add them up. 9 plus 8, that's 17. That's not divisible by 3, so this isn't divisible by 3. 4, you look at the last 2 digits. What about 5? 5 means that the last digit here has to either be a 0 or a 5, and then it's divisible by 5. 6, this is kind of fun. Because 6 is like 2 times 3 is 6, right? So if it's divisible by 2 and it's divisible by 3, then you know it's divisible by 6. 7, no rule that I'm aware of. 8, no rule I'm aware of. 9, okay, 9 is kind of like 3. You add them up, right? 9 plus 8 is 17, and if 17 is divisible by 9, then the whole number is divisible by 9. And 17 is not divisible by 9, so... And then the last one is 10, and if it ends in a 0, then you know it is divisible by 10. Okay, so let's look at this. Out of all those rules, I think the one that I remember is just it being even, right? So let's just go. So I know it's going to be 2 times, 2 divided by 98. 2 goes in there 4 times. 4 times 2 is 8. Drop it like it's hot, and 9, right? So basically 2 times 49. Now 2, that is a prime number, so I know I'm good there. I think I'm just going to highlight it. Yeah, I'm just going to highlight it. You can circle. Sometimes I circle it when I found that prime number, okay? So I know that is going to be in the prime factorization, okay? So once I get that prime number, that is a part of the prime factorization. Now, is 49 a prime number? It is not, so I have to work on that a little bit more. 49 is the same thing as 7 times 7, and what do I know about that 7? That is a prime number, and this 7 is a prime number. Those can't be broken down any further. So boom, there I have it. 98 is the same thing as 2 times 7 times 7, or how I would write this would be 98 is the same thing as 2 times 7 squared. That is our answer. Perfect. Okay, let's go ahead and look at these ones here. So we're going to write the prime factorization of each number. Yeah, and it is your turn to do it. Here is my friend the pause dragon. Remind you to pause your device. Go ahead and try A and B, and when you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. Okay, so 40, right? I'm going to use those divisibility rules. I see that it has a 0. I mean, there's a lot of things this is. I mean, it's even, right? So it's divisible by 2. You know, the last 2 digits of is it divisible by 3? 4 plus 0 is 4, which isn't divisible by 3. I mean, it's divisible by 4, 5, 10. I mean, there's a lot of stuff. I think I'm gonna start with 10, and it's gonna be, you know, 4 times 10. Okay, can I break down 4? Yes. Can I break down 10? Yes. Neither of these are prime numbers, right? So if it's not prime, it's called a composite number. So 4 and 10 are composite numbers. 49, there's a whole lot of composite numbers, right? Just anything that's not a prime number is a composite number. So these are composite numbers, they're not prime numbers, so we need to get this into its prime number. So 4 is the same thing as what? 2 times 2, right? And 2 is a prime number, and so is 2. So we can't break those down any further. So I know those 2 are going to be a part of my answer. And then 10 breaks down into 2 times 5, right? And 2 is a prime number, and so is 5. So now I'm to nothing but prime numbers. So this is my prime factorization. So I'm going to say 2 times 2 times 2. That's the same thing as 2 to the 3rd power times 5. So if you got that one right, awesome, awesome. Good job. Okay, let's see how you did on B. If you didn't, then go ahead and fix it, right? So your your notes look like mine. Okay, let's look at 33. So we're going to break this down to this prime factorization. I'm going to say that I know that 3 goes into this, 3 times 11. And what do I know? I know that 3 is a prime number and also 11. So that is it. It is broken down. This can't go any further. That's the prime factorization is 3 times 11. All right, if you got that one right, great job. Okay. Now, check it out. I got a couple more for you. Let's do C and D right here. Where's my friend? Here's my friend, the pause dragon. Remind you to pause your device, work those problems out. When you get done, press play and we'll talk about them. All right, see you in a bit. You can do it. Okay, let's see how you did. So we're going to break down 49. 49 is the same thing as 7 times 7. Those are both prime numbers, so we're done. The prime factorization is just 7 squared. And then 19, let's think about 19. 19 is not even, so it's not divisible by 2. And really, when a number like isn't even, hold on a second. Okay, so when it's not divisible by 2, that means it's not divisible by any even number. So 2, 4, 6, 8, 10, okay? How about 3? Well, it would be 1 plus 9, which is 10, and 10 isn't divisible by 3. So it's not going to be divisible by 3. Is it divisible by 5? No, it doesn't end in a 0 or 5, so no. Is it divisible by 7? It would just be 7, 14, and then 21, so no. 9, you'd add them. 1 plus 9 is 10, and 10 is not divisible by 9. And, yeah. So it's not divisible. 19 is a prime number. So the prime factorization of 19 is just 1 times 19. All right. Okay, that is it for example 1. I'll see you in a little bit for example 2.